Hello students, today we will discuss on the different types of aerodynamic drag. In the picture you can show there are three forces. One is up, one is back and another one is at the side of the left or right. So upward is known as the lift force, backward is known as the drag force and the sideward is known as the side force. Here let's go for the types of aerodynamic drag. Basically there are 5 types of aerodynamic drag. 1. Profile of from drag. Number 2 is inducted or leaf drag. Number 3 is surface or frictional drag. Number 5 is interference drag. Number 5 internal flow or cooling and ventilation drag. Let's go to the from drag or profile drag. It is directly affected by basic shape of the vehicle body as created by body engineer. Body shapes that minimize positive aerodynamics forces or pressure on the front of the vehicle and minimize negative aerodynamic force or suction on the rear of the vehicle will exhibit low from the drag. It is about 55% of the total drag. In the picture you show dragging portion. The vehicle moves in this way and this is the drag effect. In this way the streamlined body small from the drag and the blunt body large from the drag. Now come to the next one, that is frictional drag. Frictional drag or surface drag. It is a frictional resistance that results from air passing tangentially along the body. The velocity of air produced a thin layer called the boundary layer next to the vehicle body, which slows the velocity of air due to tangential friction forces. The viscous friction losses in the boundary layer and the drag on small surface imperfections within this layer are considered as surface drag. It is a small part of the total aerodynamic drag, that is about 9%. Means it is a tangential the force which is passing through the tangentially of the vehicle. If vehicle moves in this way and the air friction will be passing through the in this way in the tangentially. In the smooth surface for the small friction and the large friction with the rough surface this way. Then the next one is inducted or lift drag. It was the result of any lift force that is generated by the moving vehicle. The magnitude of the lift force is primarily a function of the basics body shape. The magnitude of the lift and its distribution to the front and rear wheels is a function of the ground clearance, the contours of the body and the underbody, and the angle of attack of the body to the air. It is about 7% of the total drag. So if vehicle moved in this way, this is the air force will be struck into the front area, then it will be moved some of percentage is moved to the under the car and our maximum mark moves from the up of the car. So this is a lift force in this way. This is the downwards force here also. This is a lift force. There is a drag in between this. So lift and downward force are the body over body flow. The next one is interference drag. It is caused by the projection and protuberance that exist on the basic body. The exterior vehicle body projection such as hood ornaments, windshield wiper, radio aerial, rear view mirror, air scoop, roof pillar, rain gutter, and all contribute to the total interference drag. The various component projection under the vehicle, such as engine pan, as suspension arm, exhaust system, and the rear system, also contribute to the interference drag. It is 17% of the total drag. And the next one is interflow or cooling and ventilation drag. It is the sum of all energy losses produced when the air passes into, though, and out of all vehicle system requiring or permitting airflow. The engine cooling flow, which is primarily internal flow component, plus the passenger ventilation flow, and any internal flow required to cool brake or other mechanical component contribute to internal flow drag. So it is about 12% of the total drag. So students, here from drag is about 55% of the total drag. Frictional drag is about 9% of the total drag. So from drag plus frictional drag is equals to 55 plus 9 equals to 64% of the total drag. Then lift and down force of overbody flow or lift drag. It is about 7% of the total drag. So the summation of these three drags equals to 71 sorry 71%. Next is interference drag. It is about 17% of the total drag. And then is interference of internal flow. It is about the 12%. Is a 12% of the total drag. So equals to the 100%. So therefore means this 55% plus this 9% plus this 7% plus this 17% plus this 12% is equals to the 100%. Now next we'll discuss on the coefficient of the drag. The drag coefficient is a common measure of aerodynamics efficiency in a automotive design. The drag coefficient is a unitless value that denotes how much an object resists movement through a fluid such as water or air. Hence, the coefficient of drag must have low value, which leads to low drag force and ultimately increases aerodynamic efficiency of the car. So student, this is the equation of coefficient of drag. Basically the equation is CD equals to D upon half of rho V square A, where D is the drag force, rho is the air density, V is the velocity of the vehicle, and A is the frontal area of the vehicle. So therefore, if we find out the equation of the drag, then it should looks like a half of rho CD V square A, D stands for drag, CD stands for coefficient of drag, rho stands for the air density, V stands for velocity, and A stands for the velocity of the frontal area. So the similar to the coefficient of drag, coefficient of lift and coefficient of side force will be find out. We find out. Coefficient of lift is equals CL equals to L by half of rho V square A, where L is the lift and other one is similar. Coefficient of side force equals to C y equals to Y by half of rho V square A. Y is a side force, because is same. So this is the equation of coefficient of drag, coefficient of lift, and the coefficient of side force. Now came to the different types of drag coefficient and the shape. How the drag coefficient is vary with the shape. If the shape looks like sphere, then the drag coefficient is 0.47. If it is half sphere, then it is 0.42. If it is cone in this way, then it is 0.5. If it is cube, then drag coefficient is 1.05. If it is angle cube, then the density is 0.8. If long cylinder, then the value of 0.82. Short cylinder, that is 1.15. If it is streamlined body, then the value is 0.04. And if the shape is streamlined half body, then the value of CD is 0.09. So students, here we will discuss on the different types of aerodynamics drag, and also we can learn here coefficient of drag. Thank you class. Thank you.